So the code looks then like this basically. Size is implemented as return, distance, begin, end, and then distance from 2 is more or less underscore distance from 2, and then underscore distance from 2 is being implemented as int, because it's not int, it's our template type. Int 0, and then it's the whatever type that is. P is equal to from, and then while P is not equal to 2, count, return the count, and of course advance from. So this invokes the not equal operator, this invokes the plus plus operator, those were the calls that we have seen, and this is how this list is being counted. So, right, okay, so it's called from this num vertices. Okay, so now we have to find out where is num vertices called from, and num vertices is here. This is the portion of the call graph that describes it. It has no, I'm sorry. How would you find it? You would search for backslash star num vertices. Okay, that's the one. So this is the one here, 2,690 calls. Okay, if you look at the calls, so there's one caller that accounts for 2,682 of the 2,690 calls here. This caller here, and then there are other callers for much smaller numbers. One call from here, 2 calls from there, 3 calls from there, and 2,682 calls from there. And this is this function. Okay, so what's the name of this function? It is operator. So well, I'm planning on having the students next semester do that. So this function is an operator, right? Okay. Remember in C++, operators are functions as well. So this is this operator. And it's an operator that applies to the dominator visitor code. Okay, so it's an operator on dominator visitor. And now the question is, where is that function called from? Let's find that. This is the function here. There were 2,683 calls. And that function is called from a function that's here, Lengauer Tarjan dominator tree without DSF. So Lengauer Tarjan dominator tree without DFS called the operator parentheses on dominator tree. Keep that in mind for now. Okay. So now we have to look in the code where that is what happened here. Okay. So. Here's the dominator tree algorithm. Okay. It creates somewhere here, namely, a dominator visitor. Sorry, the visitor is called visitor. And down here it invokes the operator, the parentheses operator. That, which looks like a function call, is an invocation of the parentheses operator. This here, right there. And you notice that this occurs in an inner loop. Okay, so there is, it iterates over the number of vertices of that graph. And for each vertex, it invokes that operator. Okay, so this is the visitor invoked in a loop. I'm there for a second. So then we look at the operator. that is the operator. And in fact, the operator called num vertices. And this num vertices here, this call is where size was invoked, where list was counted. So, what's the problem? Let us see what the problem is.
Already have the number of vertices and still counting.
Second.
The loop is executing so many times.
Well, but the loop is executed so many times, but see, I mean, it has to, right? I mean, this is the logic of the algorithm. Okay, I don't understand how they do it. Okay, I admit that. But I mean, so you mean this loop here? Yeah. Well, the problem that explodes the time is that this is the outer loop, right? Which calls this visitor, and whenever this operator is being invoked, num vertices is being called. Okay, and that leads to this n-squared explosion of calls to num vertices, which every call to num vertices iterates over the list of all nodes in the graph. Okay, so we know that's the problem. The question is, can we fix it? Remember, but num vertices, right? It counts the number of vertices in that graph. Okay, this is a visitor. Visitor is a function that does something to apply something to each node in the graph. Does it change the graph? Does it change the number of nodes in the graph?
It changes the buffer.
We could have stored them in a temporary variable. Okay. So in fact, the number of number of vertices could have been computed when that visitor is created. Okay. Rather than every time this visitor is applied in the inner loop. Okay. And as a matter of fact, that is exactly the fix that the author of the code decided to apply. So if you look at the visitor now, dominated visitor, we added a field called number vertices to it. That field is initialized in the constructor. That's the constructor. Yeah. That field number vertices is being initialized here, and then where they would previously call number vertices, they would simply use that pre-computed value. And this is where they added the field. So you can see the diff. So this is the diff. They added this field. They replaced they removed the call in the visitor where they would invoke num vertices, and instead of using this here, they're now using the pre-computed number that is stored as once when the visitor is created, and it is initialized up here in the constructor. And as a result, now the large graph can be analyzed in something like 3 minutes, and we can focus on our research. Now, so what I would have liked to have done is to find that using gprof. Here, actually, I'm going the other way. That first it didn't finish, and the student didn't think of using gprof. So instead, let's ask the author of the code. And fortunately, they knew about this bug, and we sent them that patch that fixed that. So I felt a little bit in reverse here. Okay, so I knew what the bug was, but I showed you how to use gprof to find it. And in this case, you can suggest a solution based on some basic knowledge about graph algorithms.